wish I had less time to, you know what I mean? Like, all I can do now is mess up. Hi, good afternoon. My name is Exie, and I am joining you live from Google London with my friend and colleague Sparky. And thank you so much for joining our first ever YouTube Live virtual from London. Not our first ever virtual live, but we're super excited to be here in London to tell you a little bit about our programs and also to tell you a little bit about site reliability engineering.
Well, great. Thank you so much for inviting me, Exie, to join you today. Before we get started, can you tell me a little bit about what Inside Look is and what we're going to do here this afternoon?
Well, Inside Look is my pride and joy, so I would be happy to tell you about it. 3 years ago, I was in a brainstorming session with my team, and we talked about ways that we could, everything at Google is about scale. How do we reach more people? How do we make the world's information universally accessible and useful? And a lot of what I do is going out and giving talks, giving workshops to external audiences, but there's only so far that I can go. Despite what my passport has to say and my frequent flyer miles, but we thought, what if we brought students and computer scientists in-house? Even with that, there are some limitations. Space is one of them, and we've had thousands and thousands of people express interest in my program, and thanks to Inside Look Virtual Edition, we're hoping that we can reach some of you, and so we hope that there's a pretty good group of you dialed in online, or at least someone besides my mom, although, hi Mom, if you're watching, this is my friend Sparky.
Well, that sounds amazing.
My
so
mom
great.
Or the program?
Well, obviously your mom as well.
You've been invited to Thanksgiving, so get excited. So that's a little bit about Inside Look, and at the end we'll also be hearing about some of the other opportunities, whether they be coding competitions, scholarships, internships that are available to you. And in the meantime, I'd like to hear a little bit about site reliability engineering. So you have been at Google for over 13 years now.
Yep.
You are a software engineering manager within site reliability. You have been the recipient of the Google London Citizenship Award. You have attended Grace Hopper. You have mentored many interns. You have mentored many Women Tech Makers Scholarship recipients. You are an incredibly impressive person. I've always said that in that way you remind me a lot of myself. But maybe you could, that was supposed to be I hope you're laughing at home. Okay. But why don't you tell us a little bit about what you've been doing until this very moment.
Oh, thank you. Really appreciate the compliments. So I actually started at Google right out of school. I started in test engineering, so building large infrastructure tests for systems that were running, ads or search. After a little over a year, I moved onto the developer side, so adding features to our products, building the Google products we all know and love. And then 3 years ago, I transitioned to site reliability engineering. And we call that SRE for short. So you're going to hear me say SRE a lot today because site reliability engineering is a mouthful. But the job title is all about making Google's products reliable. And our first product was Google.com search. It was a website, and so that's where the site comes from. It was about just keeping the Google site up so people could search, but now it includes our servers, our APIs, cloud platform, and all the different ways that users now access our products. So whether it's mobile apps or web or assistant and home, those are all things that we have to keep reliable.
Sounds like a little bit of a job. So when I go to google.com, it's there and it works. And if it's not there, I test my Wi-Fi connection. So is Google always working? Is it all about reliability? Can you explain what the reliability means in reliability? Well, you mentioned what the site is.
Yeah, you already hit on it. The reliability is all about it being there. Is it available to users? Can you depend on it being there? And so that's where site reliability engineering came from. It was all about engineering best practices to make sure that our sites and our entire suite of Google products were available to users and that they behaved how users expected. When you go to do a Google search, you want to get a response back in a reasonable amount of time. We live in an always connected world. You don't want to do a search and then, oh, well, maybe it'll email me with the results in a half hour or something. There are definitely cases where you want to run a more complicated process online and you expect it to take a few minutes. But we look at, is the site or app available? What's its uptime? And is it responding in a reasonable amount of time? And these come from our philosophy of user happiness being the #1 feature. In fact, we used to have a motto early on that was focus on the user and all else follows. And the users just wouldn't be happy if they went to our product and it wasn't there. They couldn't depend on it. They would go somewhere else that they knew was available. In fact, let's say your internet was down, you couldn't get to this YouTube live stream. What would you do?
I would be devastated. I do not know how I would go on. Yeah, no, I would check my Wi-Fi connection. I would make sure everything was plugged in. I think the last thing that I would think of was, I would assume that I myself had forgotten to record a YouTube live video. The last thing I would think was that YouTube was down.
Absolutely, yeah. And most of our users have computer science backgrounds, so some of them have probably done some web development, and they're familiar with what we call 400 or 500 error pages on the internet. You've probably seen some of these before. Yeah, a user would be reasonably horrified if they saw one of these, but that at least tells them that it's Google's problem. If the browser just doesn't load, you think maybe it's on my side. Well, guess what happens when we can't get our products to work? We often check the internet as well, but we're going to check a different scale of internet. One thing we would look at as global network traffic. You know, are the data connections between our data centers working? Is there a major ISP's hub that's having issues? Maybe there was a cut in a transatlantic internet data cable. There are all kinds of things that could take Google scale internet down, not just your home internet. But we also look at a lot of other different things that could be wrong. Do we have the resources? Do we have enough CPU and RAM in the server allocation virtual machine for the job that's running google.com search? Or do we have the data store? Is that accessible? Does that have the right permissions for the service to get data information out of it? Or maybe it's just grown too large and so it's really slow trying to access the user. Maybe there's been a change in our configs. There's lots of things that can go wrong, surprisingly. And in a worst case scenario, we get alerted when the website isn't reliable because it might be a major issue. Like I said, global configuration issues, natural disasters. We've had some, flooding. We have data centers in areas that get hurricanes or floods. We may have had a few fires in data centers.
And what happens when there is a fire? Two questions. What does Google scale mean? Like how big a slice of the pie are we talking about? And what happens when that natural disaster strikes?
Absolutely, yeah. Well, I mean, first of all, at scale, there's literally billions of internet users around the world, right? They're not all online at the same time, but a lot of our products could be getting hundreds of thousands or even millions of requests at any given moment. So that's the scale we're dealing with. And we look at global replication as a big solution to this, as we want to make sure that not everybody's coming into one funnel to one pipeline, because then if that fails, we have nothing to go back to. That's it.
That's a single point of failure.
Exactly.
I've been told that this is a single point of failure. I have this device on the back of my cell phone that I store my credit cards in. Would you consider this a single point of failure?
Well, yeah, if all your credit cards are in that and you lose it, absolutely.
Okay, I'll leave it here.
We'll
just put it.
I just need to buy one thing on
just
Amazon.
One thing. Okay, all right.
No, it's a
so
very
you don't want
good
a single
question.
point of failure to be able to roll over across billions of users.
Exactly, yeah. So we do a lot of replication. We do a lot of localization as well. We want your traffic to be handled quickly as well. You want a fast response, and so we might have a copy of the service running in every continent in the world. So you never have to worry about that transatlantic data cable, maybe. There's a lot of things that we can do to provision for that, but we also need to know what to plan for. So do you remember Pokemon Go?
I mean, how could anyone forget it, right?
Were you an early user when it first came out and there was a lot of people staring at their phones going, I can't see any Pokemon, nothing's happening?
Yeah, I mean, life was, as we know it, was over for that period of time.
But that's exactly the sort of problem that we try to avoid, is we want to plan for the capacity for how many users are going to be on our systems and make sure that we have enough resources. And sometimes that's hard. For a completely new product, you have to kind of guess what the user base is going to be like, how many hours they're going to be out poke hunting every day. I think that sometimes, a wild success of a feature like that, or when there was the selfie feature in Google Arts and Culture, remember where you could take a picture and it would find the artwork that looked like you?
Allegedly looked like me, but yeah, sure.
Yeah.
Okay, so you just didn't know that people would like selfies and Pokemon as much as they ended up liking them.
Okay, yeah,
that seems like a failing, but
nothing failed, but it was a learning opportunity. We go for blameless postmortem, so that was totally a learning opportunity for us. So that's what we were all about, is trying to plan ahead for that sort of thing, and then react when things go down.
And so if your job is a lot about fixing things when things break, how do we get back online? How do we load balance? Would you say that you are just running around after software engineers fixing the problems that their fancy, shiny features have created? And are you always at odds then with the people who are building these things and the people who are trying to manage them at Google scale?
Absolutely not. No, we're very collaborative in that case. And we're also very proactive. So we work very closely with the devs at the beginning stages, when they're designing a new system or they're adding a large feature that might add, new data storage or communication between multiple servers. We want to be there to do that consultation to say, this is where your single point of failure is. Hey, by the way, you are depending on somebody else's product, but they only run in this data center that's over here. Have you told them that they need to scale up? That sort of stuff. So we do a lot of proactive work. In fact, we try to be more like 80% proactive work, looking at where things could be made better and especially automating that. So remember, when there is a fire or a flood or even something really small and we're no longer able to serve traffic out of one data center, I don't want to get alerted. What I want is a system that can automatically detect, hey, this data center is no longer responding to traffic or even to just these types of queries for this one server, and it's going to dynamically allocate those requests to somewhere else that is successfully serving traffic. So that's what we want to do in SRE, is build that sort of automation and tools that handles the alerts and fires for us. And then we get involved when there's something that we've never seen before, so we haven't built automation or a smart tool for.
Awesome. And so you mentioned earlier, localization, and now you've just mentioned we get alerts. Does that mean, it sounds like it would therefore not make sense to have all of site reliability here in our London office, as beautiful as it is?
Absolutely. We are distributed in, let me do a quick count, somewhere around 10 sites globally. So we have 4 here in Europe, we have Sydney, as well as at least 5 sites in the US. And in fact, we work split teams, so half of our teams are always in one continent and half are in another, in pairs, so that we aren't around the clock on call. We do 12-hour on-call shifts, so during your working days, and then we're paid for a few extra hours where we might get paged in the evening or morning before it switches over, in my case, to my San Francisco counterparts.
Wow, really interesting. And how do you know what you want to automate or what tools you want to build first? How do you weigh those decisions? Because it sounds like you could have any number of things that you would want to prevent against if you become ingrained in this risk aversion mentality.
Sure. Well, it's about acceptable risk, first of all. And to understand what's the acceptable risk and what we need to fix, the first thing we need to know is what the problem is. So the first thing we do is not to build any tools or automate anything, but we measure it. Metrics are our main job. So we go in and make sure that there's accurate logging and counters throughout the code in important user actions, in crash paths, and those sort of things, so that we can really tell what's going on. So we know that the number of users who are coming and signing into the tool, and how many are then getting to the second page, or starting the video, or uploading a video, and how many video uploads complete successfully. And we get metrics on all of that. And then we look for cases where the metrics don't look healthy or the users don't look happy. We also have explicit feedback tools on all of Google's products where users can report things that are behaving incorrectly. Definitely look at those as cases of, this is what we want to handle. And so by collecting those metrics and that data, we can actually process millions of data points every second into our monitoring systems, and then compares the system's performance to our SLOs.
Okay. What do you mean exactly by SLO?
Oh, sorry. Yes, that's a service level objective.
Service level objective.
Yes, that's the threshold for acceptable reliability. So we set an objective, usually a percentage, such as whether the website should be available to users. What's an acceptable uptime for the user access to a website? And then the monitoring system knows whether we've achieved that or not, and it automatically alerts us or kicks off a process to heal something, such as moving the traffic around, if we're not achieving that threshold or SLO.
And so is the goal 100% reliability? Is that right? Like, we always want users to be happy. I mean, sorry, it just seems like I would always want it. I want it right now, right?
Of course, no, I mean, user happiness is important, but that does come at a cost. So there are systems that are critical, that are life and death, and those absolutely are worth the cost to ensure that they work correctly 100% of the time.
Like
so
what?
Pacemakers, airplanes.
Is that what that is? That, like, let's see that image. Is that?
That is a
not an airplane.
pacemaker.
Okay, that's
yes.
a pacemaker.
I know.
A fascinating airplane.
At one point in university, I looked at interning at a company that made pacemakers, and I was like,
Huh.
I'm not sure I want to be responsible for that.
Okay, and so, all right, I think we've seen the pacemaker, but so there's an example of something that you cannot have fail.
Exactly, yeah. Whereas in computer systems, actually, there is a lot more chance for fail. Like, I get that it sounds important when you're, in an argument about what year that movie came out, and you know what year, and you want to prove you're right.
I do.
But if Google search is unavailable for a few minutes, there's not a life or death risk there.
Right.
And so we have to look at the cost trade-off. And especially when there are humans involved in this system, we can't expect humans to be available sitting in a computer 100% of the time to make sure that they can react. And there's also just an amount of time that it takes them to react, to understand something is wrong. Our monitoring does take a few minutes to process all of those millions of data points that are coming in, to know how to fix it and to push that fix live. It would be prohibitively expensive. So that's why you hear things like 3 nines, 99.9% uptime, or 4 nines, 99.99% uptime. And that gives us a measure of what's acceptable downtime versus uptime and what we want to aim for in our service and how much money and SRE support we're going to throw at getting that up to that reliability standards.
Okay, and so airplanes, pacemakers, that makes sense that we want 100% reliability. Yes, when I want to look, I do a lot of pub quiz, so I would want the information.
Not
quite
during
quickly.
the pub
Not
quiz,
during,
I hope.
but afterwards, while they're like the grading, it's very intense, very.
Right, you want to know the score before it comes back.
Yeah, exactly. Who has time? Who has time to wait? But what would be an example of something where you just decide a bit more latency is acceptable?
Sure, well, let's talk about YouTube Live. Yeah, obviously we want it to be up 100% of the time, but let's say for 2 minutes every day you couldn't upload videos, where the user just got a message that said like, hey, uploading's broken right now.
But I could still watch the cat videos that are already up. I just couldn't upload new videos.
Well, they probably have different SLOs, but yeah, like obviously we have some cat streaming issues here. But yeah, in general, we'd like to hope that some users who might see the effect would understand that systems go down or systems need to be updated, that sort of stuff. But we do really strive for having 100% uptime most days. We tend to look at SLOs on the scale of months or even years. 4 nines is still only a few hours of downtime over an entire year.
That's amazing.
And that can make the news. When YouTube goes down for a few hours, definitely the global news notices. So we measure ourselves by how well we're, keeping user happiness up. And it's kind of one of those invisible jobs. If they don't see that the site's gone down, we've done our job well.
Yeah, and I think that's really interesting because software engineering is something that all of you who are watching at home or at campus, wherever you are, you've heard of software engineers. People know what software engineers are, but site reliability engineering was really, we literally wrote the book on it, and that's a kind of a Google homegrown, or at least calling it site reliability engineering is something that we have come up with.
Absolutely, yeah, we were the first to call it that, and we did write the book. In fact, this is our second book, the Site Reliability Workshop. If we pop up the slide as well, it has the cover of our first book. Both of these books are available, I believe, for free online now, so there's a link there to landinggoogle.com/SRE/books, where you can download them and read them for free if you'd like, or you can purchase the copy in any O'Reilly store or Amazon. It really talks about how we do it at Google scale. It doesn't mean that every engineer or every startup or even every individual like doing a project for themselves should be following these practices. And in fact, they're more of an amalgamation of best practices we've learned over many teams and many years to think about all the different factors that can influence reliability. It's not a magic solution or checklist to follow. It's definitely an evolving field that we are still adding content to every day, and that's why we've published a second book about practical applications, as well as a number of articles about how to specialize in different types of reliability.
not to brag, but my emergency contact and best friend is one of the authors of this book, so no big deal. Hope he's watching. Cool. And so just getting back to, how do you set those? And it sounds like you're not really, do you have to work with feature developers as you're coming up with these, or are you pretty separate? You don't have to work with them at all?
Oh, we work with them quite a bit. We're normally talking to our feature developers at least every week or every other week, particularly around coming up with these SLOs around what's acceptable behavior for their system, because they know what's going to be technologically feasible or what they want, and then we come in, like we said, early on in the process when they're designing the system and give them some guidance of, oh, well, if you want it to be faster, here are some suggestions for how to do that. Here's how we would set this up on the networking side, or here's how much it's going to cost. Data center resources aren't free. If you want to run in every data center that we own globally, that's going to cost quite a lot as far as resources. Is your product worth that? Is it going to recoup that cost? Is that an investment the company wants to make? We also talk to the product managers about what they consider to be acceptable user happiness, and so we can set the SLO thresholds based on that, and feedback from the users. But we're also talking to the devs regularly about outages that happened. They're part of solving that solution with us or giving us feedback about what they did, and they're part of the escalation chain. Sometimes a dev hears about an outage and asks us to get involved. So
when you say a dev, you mean a software developer?
A software development,
okay.
Yeah, feature development. And that's actually brings me to a good question I have for you. So we're talking a lot about these different engineering roles at Google, but how do our listeners today become engineers at Google?
That's great segue. There's really one way, and that is to apply. So for those of you who are watching at home, if this is interesting to you, what Sparky is saying, if it sounds like engineering might be something that you want to pursue, I do have a few pieces of advice for you. And the first one would be to apply. So it is a very rigorous process, and I can't promise that you talk about 100% reliability. Not 100% of the people who apply are hired, but I will say that 100% of the people who are hired did apply at some point, so that's a pretty big barrier to entry. So if I could give one piece of advice, it would be to do that.
But what about that? I mean, besides applying, there's got to be some other things they should do. Sure.
So basically, earlier when we were talking, you said I could talk forever about site reliability engineering. And honestly, I believe that you could, and I could listen forever. I find it really, really fascinating. And I think that that's something that's important. We look for people who love what they do. So when I bring my mom in for an office tour and I show her the ping pong table and the bouldering wall and all of that stuff, she's just like, when does work get done? And the reality is that work gets done all the time because we love what we're doing, whether it is giving tech talks, building SLOs, building in features, and so we look for people who are passionate and who love what they're doing. And there's a few different ways that you can showcase that passion, showcase what you love doing, while also building your technical skills. So few of them are offered by Google. One of them is called Hashcode, and Hashcode was actually started in our Paris office, which I'll be visiting later this week. I'm very excited. And it is basically, there's an online qualification round where teams from across the world compete, and then the top teams receive a travel grant and they get to come to the final round, which is now hosted in Google Ireland in our Dublin office. If it's something that you think you might be interested in, please do it. It's free to enter. You don't have to apply to enter. It's really, really, really quite simple, and it's a fun challenge because it mimics a real-life Google problem. So one was around how to optimize for street view cars, traffic patterns in Paris, which I thought was really neat. And as you're working on these real-life Google problems, you're getting a lot of hands-on experience, but then it's also something that is a really good thing to put on a CV. And if it's something that's interesting to you, you can actually register to host a Hashcode hub, and the link is up there. But you can sign up, host a hub. We'll send you a bunch of cool swag and promotional material and some advice on how to get started. There's also another one called Kickstart, and so Kickstart is another online coding competition, and that really is for developers of all skill levels, and you don't get booted out in the way that Hashcode, there's 2 rounds. There's the online one for everyone, whether you're an industry professional or a student, and then if you do well in that, you go to Ireland. This one runs throughout the year, and so you can always opt back in. You can always take it one step further. And the next round is coming up on October 19th, so that's pretty exciting. So being prepared in those kinds of things and showcasing not just your passion, but also getting that experience through programs like Hashcode and Kickstart, I think is really important. And that's something, that passion for technology is something that we look for. I think it's important to have, not just for our full-time roles and for our interns, but it's also something that we look for our scholarship recipients. So one of my favorite parts of my job is giving away money. I'm great. I really am fantastic at giving away other people's money. And 2 of the scholarships that I work with are the Women Tech Makers Scholarship Program, which I know that you're quite closely involved with, and the Google Europe Scholarship for Students with Disabilities. So both of those links, those are up there, but those are ones where we're really, again, looking for a passion for people who really care about the field and care about the industry, and participating in coding competitions. Or this weekend I was at Hack Zurich, which was super fun. Anytime you participate in that, even if you don't place, so be memorable. One of my favorite CVs that I ever saw, somebody had in like interests and accomplishments, 11-time marathon attempter, and I think that's fantastic. So participating in these things, scholarships, all sorts of things, those are really great ways to apply and to showcase your interest while building your skills.
That's fantastic. Yeah, like I said, I've worked quite a bit with our scholarship winners, and yeah, many of them do have hackathon experience, but so many of them have other experience, whether it's community building or teaching to younger students, passing on that love of computer science. I think that I'm always impressed at the variety of experiences that they bring.
I couldn't agree with you more. It is the highlight and the low light of my year is reading the scholarship applications. Highlight because I am so humbled by them. Low light because I have to select some to get it and some not to. They are, I mean, we're not bad, but they're next level impressive.
They're very impressive. But yeah, if anybody out there is feeling like we're discouraging you from applying, that's definitely not what we're trying to do. Like I said, there's so many people who are doing research or are just really crushing in their classes or are demonstrating passion through any number of ways. So please send us your applications.
I would also say that there are a lot of people who say, well, at my university, I don't have the option to take this until second semester or until this. A GitHub profile goes a long way. One of the things that I love about a lot of what's done at Google is that it's made public, it's open source. There's so many different things that you could get involved with. If you have a GitHub profile, you will find people who want to partner with you. You will find projects that you can get involved with, and you can do quite a bit with the stuff that Google makes available as open source collaboration.
That's awesome.
Yeah.
So we started with they should apply. So where should they apply, or how does Google find them?
Sure. Please don't let Google find you. Don't wait for that to happen. Apply, so google.com/students, and if you have signed in on the link that's popping up under this video, then don't worry, we will show you where you can go, but google.com/students, it has all of our opportunities and our internships, and we would much rather you, actually, I made that slide at the Google Zurich Pride TGIF, which is our happy hour on Fridays. I had a little build your own Android. So those pom-poms are from my home stash. I think my mom actually bought them for me at Michael's craft store. Anyway, but yes, you should apply. It has all of our opportunities. When we're talking about EMEA, so Europe, Middle East, and Africa, we are talking about Munich, Paris, Dublin, Tel Aviv, Warsaw, Stockholm, Zurich, London, Haifa, Aarhus, and Budapest. I feel really proud because I didn't need my notes for that. So lots of different options, and really, really encourage you to check them out.
Okay, wow, I didn't even realize we had some of those offices. How do the students decide which office or which product team they should be applying for?
Great question. You don't have to worry about that at all. So as you know, Sparky, when we hire at Google, we look for some really, really fundamental engineering skills. We're looking for engineers who are generalists, and you probably know that because you have had people yourself included, move teams a lot within Google. You have had people who report into you, move on to other teams, and you absorb other folks from other ones. Maybe they have been coding only in Java, and now you need them to code in C++. That shouldn't be a barrier. So we're looking for people who have fundamental, solid foundations in data structures and in algorithms. And so when you apply to the internship program as a whole. So you don't have to worry about, should I live in Zurich or should I live in Paris for the summer? Because that is a very difficult problem to consider. You would just apply to the engineering internship, and that would encompass both software engineering and site reliability engineering. And it's totally fine if you say no, but my heart belongs in Stockholm, which I would understand. Capital formed of 11 different islands, trivia fact.
Nice.
And I absolutely want to work on real-time. I absolutely want to work on real-time communications. Well, that's totally fine. But again, you would just apply to that internship program holistically. And then if a recruiter was interested in your profile, they would reach out and they would say, tell me about what you're looking for, and match you appropriately. So you don't need to stress about which one. You're just kind of applying to that program holistically.
Okay, so great. So they apply to a general internship. They talk to a recruiter about which office they want to work with. So other than that, are all the internships the same?
Close, almost. So within the EMEA region, yes. So within Europe, Middle East, and Africa, for the classic software site reliability engineering internship, yes. But there's also our STEP internship, which is for students who are in their first or second year of their bachelor. So it's really an entry-level internship. And then there's also a separate internship for PhD students. But both for STEP, for the regular engineering internship, which is open to any student, whether you're bachelor's, master's, or PhD, as long as you will be returning to university at the end of your summer, at the end of the internship in 2020. All of those are open to you. If you're in a PhD program, we would ask you to apply for the PhD program internship, and none of them are exclusive, meaning if you do a STEP internship as in the first year of your bachelor's program, you can come back the following summer to do a site reliability or software engineering internship. The following summer, then you say, I want to go get your PhD, great. You can come back and do an internship with us during your PhD. I met somebody this summer who was on her 4th internship with Google, so that's totally fine. Yeah. And it's interesting actually, because just as we are encouraging you to get ready and get applying for those, as you know, as a manager, you are also writing internship applications, right? But not to be an intern, sadly. But you're writing project proposals to have an intern.
Absolutely, yeah. So we have to define why we need an intern on our team and make sure that we have a good scoped project. It's really important to us that the projects that we give to the interns are achievable in the time frame that they're here and the right level of technology, so that they don't have to ramp up on something they've never heard before. They might have to learn, a little bit of a new language, and they'll definitely learn new Google APIs, but getting the right size project is really important because you want to make sure that the interns have an amazing time while they're working with us.
Right, so that's super important for us, and also we're not just hiring interns and say, well, we'll put them on some project and they'll just be coding away for us. We really do want it to be a robust project, and so each project is actually unique, and that's why you said if you could give them one piece of advice, well, that would be apply. The second would be apply early. All of our applications are reviewed on a rolling basis. So imagine that there are N number of internships available to you in Europe. It would break my heart if you were the N+1th person who was super qualified and applied. But not only is it helpful for you to apply early, but assuming you're successful through those interview process, through those interviews, you would have a lot more selection power, if you will, in terms of what projects are left and what projects are available to you.
Absolutely, yeah. Look at you using the computer science lingo. You're hanging out with us enough.
Fun fact, I learned how to code when I was working here at Google through an internal program, so I am pretty proud of my lingo. Thank you for noticing. But yes, the sooner you apply, absolutely the better.
Great. So when do applications start?
Drum roll, please. Very exciting. Actually, October 1st. So that is tomorrow,
oh my
right?
Goodness. Yes,
wow,
it is.
Time flies. So applications open tomorrow, October 1st, for our classic program. You want to check back I believe, on the 15th for the STEP program. So that's the program for first and second year bachelor students. And the way that you can do it is you go to google.com/students. And then it's really important that you filter by location. So any of those locations that I mentioned earlier, Zurich, London, Paris, Stockholm, look up those and you'll find the software and site reliability engineering internship. And when you apply for that, you've applied to all of those product areas across all of those offices.
So they don't need to pick a site, but they do need to pick a site.
Well, yeah, exactly. You just find the one that is the European one, because we do have internships across the globe, but it is much, as you said, we like to invest locally. So just as you want to have your data center nearby, we want you to intern locally. So yeah, check it out.
But they can find
tomorrow.
the general application under any of our sites. So just pick any of the engineering offices, find that application, and then we can route you to any office.
Yes, and you just need your CV. If you have a transcript, that's great. An unofficial one is fine. If you're a first and second year student, don't stress. I know it's early days, so no worries on the transcript.
Sounds good. I was about to say, I think some of our students are just starting their school year right now.
Yes, back to school season.
Is there anything else for our viewers to keep in mind today?
Yes, so there's a few resources that I'd like to point you to. One is if you go to g.co/buildyourfuture, everything is on there. So there's a link there to our full-time roles, to our internships, but also to any of our development programs. So that would be scholarships, the Inside Look program that I'm the program manager for is on there. Any of those kinds of resources, Hashcode, Kickstart, and then the Google Tech Dev Guide. So this is a guide that we've put together that I think is really, really helpful, and it's actually something that I was doing and sometimes I refer back to when I want to brush up on my code, because it is like a second language. If you don't use it, you lose it. And so the Tech Dev Guide has all sorts of different modules, from very, very baby entry-level ones to more advanced, and that's a really great way for you to get prepared. And then lastly is, I believe we're going to put up for you, there's a link. If you fill in this link that's there, you'll be asked to fill in a little survey, and then if you give us your email address, you can win a virtual mentorship. This is something that I piloted last year, and it was super successful. If I may say so myself, I realized that sounded maybe a bit, well, it was very successful. If you fill in this, we can enter you to win a virtual mentorship. And what does that mean? That means that just as we've been having this virtual Inside Look session today, you can win a one-on-one mentorship either with a Google engineer, a site reliability engineer, a software engineer, or with someone like me who's happy to give you some coaching advice as you're trying to figure out your next steps. So please do visit that link. All we need is your email address, and then we will let you know if you're one of the lucky winners who maybe gets to spend an hour with me virtually. Cool. So with that, how about we take some questions from the audience? I hope that people at home enjoyed learning a little bit about site reliability and about some of the things that we do here.
Well, also learning about all of the programs that you've brought as far as the virtual mentoring and Inside Look. I hope you guys tune into more of these in the future and take some time to send us some questions. We're here for another 20 minutes or so.
Yeah, so what will the SRE interns work on during their internship is our first question. Sparky, what will they work on?
That's a very good question. Yeah, so we really love having interns in SRE. Our job involves both production system changes as well as the development of that automated tools, as we mentioned. We generally don't give them production system access just because 3 months isn't a lot of time to ramp up on that. So we focus them on the tooling and systems that we're building to try and automate that, or the monitoring and metrics that I mentioned as well, like getting the right data to set those thresholds. So they end up doing projects that look like software engineering projects with a bend towards reliability. So they're going to be writing code, whether it's a pipeline to process data, or launching a new tool or a dashboard to graph some of that data and make it visible. All of those things are ways that SRE interns can really help their team and provide another set of hands helping the product. They'll also spend a lot of time learning about the product that we work on. Each SRE team owns a set of products, whether you're Gmail SRE or Maps SRE or YouTube SRE, you'll get a good sense of how that dev team works, how those software engineers who are developing the features are working. You'll get to meet a few of them and kind of see how that relationship works as well.
Yes, and in fact, I know your SRE intern from this past summer, a friend of mine who I met on campus a few times.
Well, yeah, it's her third internship, as you mentioned, returning intern.
So what a little overachiever.
I know, she's awesome, and this is actually her first internship with reliability engineering. So she had done the classic software engineering internship last year. I really think that's great that she's getting that perspective of different types of jobs. So she'll know after graduation, which should be next year. I'm watching you, Dasha.
She's also watching us. I think I made her tune in. Yeah, and I think that actually that is to further answer a question that hasn't perhaps yet been asked, but that is something that is important to note, that there's a lot of transfer between SRE and software engineering. So between site reliability and software engineering, it's not you are now on this path forever, but that in both directions. So we have software engineers who decide that they want to become site reliability engineers and vice versa. So if that's something that you don't know yet whether or not that's which you want to do, want a Google internship? Why not have two?
That's a very good point. As I said, I did feature development for 8 years before switching to site reliability engineering, and I think that was a really good move for me because I wanted to see more about how our production systems worked and how things scaled up. And that actually leads us to the next question we have from our viewers, which is asking, what are the unique challenges to SRE, and how is SRE and their challenges different from SWE or DevOps engineering?
SWE being
software engineering. Exactly, yes, thank you. Yeah, having that perspective of being in both teams, I wanted to do SRE, and I initially signed up for a 6-month rotation to try it out because I had never worked on the production scale of stuff. Often when you're building software or features, you're thinking, okay, this has to work for millions of users or even a billion users, but you don't see that in the same way. You go, oh, okay, I need a storage solution that scales very big, or I need to have this replicated, but that's kind of abstracted away from the feature developers. And so this gives me a much more hands-on, tangible view of that, as well as understanding the production stack behind the business logic. So what happens when something is written down, in a data center, when we're storing it? Well, how are we storing it? What servers and infrastructure exist behind the scenes there? What data stores do we use? How do we cache things? What different solutions do we have for different types of storage? Do we want to have a data store that's fast write and slow read? Somebody who's just, logging actions, but then, we want, very slow aggregation over it. Or is it something where users are going to be doing live queries against that data store, and so they need to be getting faster responses? I can actually understand the pieces that make that up, whereas a developer, I just knew there were 2 choices, and it was like, oh, okay, which problem set does this fall into? Understanding the how of it has really helped me to flesh out my full stack understanding as an engineer, and to think on the scale of 1 billion users. To the second question, how are we different than software engineers? I kind of answered that. How are we different from DevOps? We are similar to DevOps in a lot of ways. DevOps is developer operations. It's a combination of software development and operations fields, which is a name that's been used for like IT and sysadmin fields. We also are all about applying the engineering principles to operational problems. So operational problems are things like, my service has run out of RAM, or my network is down. And 10, 15 years ago, most companies, when that happened, there would be a human who go in and change the configs or plug in more machines or whatever. And we want to apply engineering solutions, which is automation, scaling, reliability being done by the computer itself. Not quite an autonomous smart system yet. I have yet to have a computer decide what to do, but I can give it a set of rules and it can say, oh, in this situation, I need to dynamically grow my footprint, or I need to transfer traffic to another data center because I'm out of capacity. That's where software engineering principles are being applied to those operations problems. And definitely similar to DevOps in that we're just trying to put a lot more structure around best practices and culture in place to really make site reliability a codified field, a subscience of computer science.
Cool. So that's something that on the subject of how are these two groups different. And our next question is a nice segue, which is, what would we say all Googlers have in common? And it's a tricky one to answer because one of the things that I love about Google for a while, that Android had a big campaign that was be together, not the same. And so actually a lot of Googlers have not a ton in common, right? We meet people from all over the world. There's a huge amount of diversity in the company. Both Sparky and I are involved in a lot of employee resource groups. We like to play with our names. So if you are a dog owner, you're a Doogler. If you are in Zurich, where I'm based, you're a Zoogler. If you are in the LGBTQ plus community, you are a Gaygler. If you're a Googler of a certain age, you're a Graygler. If you are celebrating Rosh Hashanah, well,
this might be a dye job, but I'm going to call that Graygler.
Okay, you're now in the Grayglers unofficially. If you're celebrating Rosh Hashanah right now, you might be in the Joogler community, and so on and so forth. So there's a lot of different ways that we actually celebrate our differences. But in terms of what we have in common, for me, I think it's a love of learning. You hear a lot of times people talk about, oh, intellectual curiosity, and I don't think that really cuts it at Google. I think it's not enough to be curious. I think we look for lifelong learners who actually go out and do something with that curiosity. I'm curious about something, I will learn it. And whether it is learning to code or learning how to boulder or learning how it is to be in an SRE rather than a site reliability engineer,
or learning Python if you're in the student outreach team,
or learning Python. I think all of those things that sort of we're always iterating. Not only are we always iterating on our products, but I think we look for people who are always looking to iterate on themselves and kind of don't cut themselves slack. Sometimes I will ask someone, hey, can you help me with this? And they'll say, I don't know what the answer is. I'm the wrong person to ask. So I'll go ask somebody else. But that original person will follow up and say, like, I'm not the right person, but I still want to know the answer. Did you find it out? And so that kind of thirst for knowledge and not saying, well, that's not really my wheelhouse. That's not my responsibility. That's not my area of expertise or interest. I don't really see that here. I see that kind of constant thirst. But what would you, and sort of segue questions, what would you say that Google's culture is like, Sparky?
Yeah, I think I completely agree with what you said. And a big part of our culture isn't just that thirst for learning, but that thirst for making things better. You know, when you see something that you don't know about, you want to understand it and you want to improve it. And so we so often have individual Googlers come up with solutions to problems that, you know, just nobody else saw, or they saw but didn't know how to solve. Somebody will just get really motivated and say, oh, this looks interesting. I want to dig into this. A number of our products started that way. You know, Gmail was somebody trying to hack a solution to they didn't like their inbox being flooded and not being able to follow a thread of conversation. Or Google News, somebody wanting to not have to go to multiple news sources to compare different news perspectives. So that's always been part of our mentality. And so what we're looking for and what our culture is made up of is people who are independent problem solvers, who see something and go, ooh, I want to know how that works and I want to fix it. It's not enough to leave something broken there. And that's part of the culture, is we really are all together. And I love that Android slogan because, yeah, we definitely see like making the corporate culture better, part of everybody's responsibility. So we really function as a community and as a culture. That's not to say there's a right way to be a Googler. We want to be inclusive and have everybody be able to bring their own interests, their passions to the workplace, but do it in a respectful way where we're all making it better and including each other and learning from each other.
And I think, you talked earlier about, we want to look at metrics and we want to look at data, and that's how we set SLOs, and that's how we determine, what's an acceptable amount of latency. I think also that's something, ironically, that is in our culture as well, is like, if you see a problem and you have the data on it, if you present that at any meeting within Google and you say, like, here are the metrics, like, we're not recycling enough or we're not doing whatever it might be, it will get noticed. So that sort of data-driven culture, while still being a very human culture, I think is something there. All right, can you talk more about the interview process? I can kick us off with that, and then maybe you as a seasoned interviewer can give us some information on that on the other side. But if you're talking about internships, you would apply online, again, to that one internship if you are not a first or second year student, not a PhD student. And if you were contacted by a recruiter, then you would have 2 phone or video interviews after that, and that would be the internship interview process. For full-time roles, you would have those 2 initial phone or video interviews, and then you would come on site. During those, we're going to be assessing your technical skills, and I have no doubt that all of you who are watching at home can code and can code super, super well, but I do have some doubts as to whether or not you could do well in a technical interview, because as Sparky can tell you, it is a bit of a different format. So you would be in a room, and there would be a whiteboard, and you would, instead of just writing your code nice and calm and peaceful and quiet, you would have to write it out on a whiteboard, or if you were doing it over the phone or over video, you would have to do it in a shared Google Doc. And it's a completely different skill set to do what you are used to doing in your terminal alone versus explaining it the way, you know, when you were in kindergarten and the teacher would read. I was always impressed, like, imagine if I could read this book to you right now. That's how you have to code during an interview. And that is a skill that I really, really, really encourage you to practice, whether it is explaining what you're doing as you're writing it in a Google Doc or explaining it as you're writing it on the whiteboard. That's something that you're going to want to do. We want you to code in your strongest language. We do want to see at least one of the following, not all: Java, C++, Python, or Go, your pick. And we're really trying to assess your thinking process. We're not going to ask you any brain teasers, unfortunately, no pub quiz trivia, but we want to see your thought process.
Definitely. Good news, we've actually in most sites moved to not requiring the whiteboard anymore. We now have laptops in the interview rooms, so if they prefer to type to standing at the whiteboard, that is an option even for the on-site interviews. But they're often, you know, a laptop with a keyboard setup that might be different from yours. So it's definitely a completely different skill. I highly recommend, as Exie said, like getting together with a group of your friends and practicing writing code up on the whiteboard or asking each other interview questions, and thinking about that sort of problem solving. There's a great blog, I hope it's still up there. It was about 10 years ago that I read it. It was on the Joel on Software blog about what an interviewer is looking for. So use your favorite search engine to look that up. You know, what is a software engineering interviewer looking for? What sort of thoughts are going through their head? And to be honest, we're looking for how well are you going to do in this job overall? And that's really hard to get in 45 to 60 minutes. So we're looking for, can you carry on a conversation about the technology or the problem that we're discussing? Like, do you have some sense of what questions to ask? Or what are some possibilities? Can you compare trade-offs of different solutions? So you might say, oh, I could do a depth-first search or a breadth-first search, and explain why you're considering both of those, what would be the positives and what would be the negatives of each of those choices. You know, showing that is sometimes more important than just writing the right solution, because if you just write out the code to a breadth-first search, but they don't know why, they're not sure how you're going to apply that when you come to a new and ambiguous problem. Because, surprise, in the real world, it's nothing like a university textbook where these are all problems that have been solved before, and we're asking you to learn them and solve them and prove that you know how to solve that. We're going to give you problems that no one solved before, because that's what you're getting paid for, is to solve it for the first time. So really figuring out how to apply those common data structures, those common algorithms, the stuff that you're learning every day in university into new situations. Again, pick your favorite search engine, go look for software engineering interview questions, and practice answering those. There's tons of resources online. It's also one of the big reasons we recommend doing hackathons or coding competitions, because those also kind of replicate that here's a new real-world problem that you need to apply the computer science fundamentals that you've learned to, in a novel way, put these pieces together to make a functional solution.
Awesome. So let's see, next question. Does P equal NP? No, you will not see that also on an interview.
I think that's a bit of a trick question.
It's a little bit of a trick question. You're not going to get does P equal NP, but What's your favorite part of your job? Can I take this one? Because I have a really,
Absolutely.
really favorite one. It's this. So I don't know who you are right now, but someone is watching this, and after this, you are going to apply for an internship, and you're going to get it. And I'm going to be so excited. I'm going to be so proud of you. And maybe it's more than one of you. I don't know. And we haven't met each other yet. But someday we're going to meet, and it's going to be amazing, and I'm going to have goosebumps, and I'll be so, so excited. And I know this is true because it's already happened, so we have a prior for this. The very first Inside Look program that I put together, there was a young woman who I selected to come to my program in Zurich who was not able to attend. She didn't get her visa, and she couldn't come. But she then tuned in to a virtual event like this one, and flash forward, it did take a while. 13 months later, we met in person when she did her Noogler. Again, we play with the name, New Googler, orientation. And she is now a software engineer on YouTube in Paris. And she had never been outside of Egypt before, and we're now friends, and that is awesome. And so I don't know which one of you is this year's version of that story, but that is my favorite part. Giving away other people's money, maybe I sound a bit flippant when I say that, but I do love it. I mean, it's great. You can afford to be so generous when it's not your money. But I love selecting scholarship recipients. I love being able to, run a program that brings people from countries all over the world in-house. But when I can't do that, I love doing these things. And I hope that whoever you are watching at home, that if this has been helpful, that we will get a chance to meet when you are a Noogler and when we are not just strangers over the internet, but teammates. So that is my favorite part. Let's see if you can one-up that, Sparky. What's your favorite thing?
And as I mentioned, my job's invisible. When I do my job really well, nobody sees it. But there's definitely something I love. I started site reliability engineering for a 6-month rotation, and I really enjoy seeing that because we get to see the nuts and bolts of how the system works. We get to hear about some really amazing and interesting outages and disasters and fun times, and we really get a sense of how fragile and yet how robust the global technology and internet is, like something that every moment of my day I'm connected to, whether it's my phone or my work or everything, is realizing all the work that goes into it. I really appreciate that Google gives me that sense of it. And the best part is actually I get to work with just kick-ass coworkers in every part of the job.
That's awesome. So your job sounds really cool.
Your job sounds really cool.
Can I give away money? We're the Mutual Admiration Society. But we talked about the Google Tech Development Guide. There's some good resources for that. But are there any tests that those who are watching at home can do online, or do you have any particular advice for assessing any algorithm skills or designing systems?
Actually, yeah, like we said, there are a lot of online tools to at least practice your programming skills. I don't know if there's a way to test it per se, but things like Kickstart that you mentioned, like that's a great way to put yourself up against other coders and see how they rank. And literally there's HackerRank, which does that. But remember that in those cases, you're competing against people from a huge broad range of backgrounds, some with decades more experience. So it's not about getting to #1 at HackerRank will get you this job. It's about saying, where am I at? What skills do I have? And as an individual, where could I have gone faster? Definitely looking at that. There are some interviewing clubs. That's a really good way as well to test those. And talking to engineers from a broad range of backgrounds. So reach outside your university and your group of friends. Talk to people and say, hi, I'm just curious, like how you would solve this problem, or if you ever use this data structure in your job. Quick tip, we almost never use trees. I know, they're really important to the data structure class, and they're fantastic theoretically, and there are places where trees make a lot of useful additions. So for a lot of, say, hashing algorithms for data storage, look, I'm Exie is getting that, nope, you would be on me. That's where, a tree might be the right use for looking up that sort of a key. But as far as day-to-day job, almost no software engineers are writing trees. So focusing on what are the most important data structures, hash tables, and the right algorithms and skills. But it's not about memorizing those. A lot of times it's about applying the simplest data structures and algorithms, or finding the right few pieces to put together in the novel way. picking the most complex algorithm is rarely the solution because it needs to be maintainable, it needs to be understandable by other software engineers who are going to be working with this code. 2 years later, when you come back to this code because there's a bug in it, you want to be able to remember why it does that. And so picking something that has that longevity is really important.
Cool. With that, the last question, what is the virtual mentorship with a Google? So if you click on that slide, that's a feedback survey, which is completely anonymous. Once you click submit, so again, totally anonymous, once you click submit, you'll be linked to one other thing, which is they're totally distributed. That is just one question, which is, what is your email address? Enter that email address, and I will be picking, I think I have 5x'd or more. I've really grown the program, so a lot of people will be receiving these virtual mentorships if you sign up, and then you will connect over Google Hangouts. You'll have a video chat or call with a Googler, and it's up to you if you want that to be with someone like me. It'll probably be me because I really enjoy doing them, or with a site reliability engineer or a software engineer, and they can either provide you with advice on your application for a scholarship because I want to give you some money, or they can provide you with advice on a coding problem that you're working on. So it could be technical, or it could be some more career coaching. But we'll be giving away a lot of those. And with that, I think it's time to say goodbye. Yay, we did our first confetti. I love it. Yeah, I've been holding that for a while. But yay, I hope you win a virtual mentorship. I hope that you apply online. I hope that someday that we are co-workers, or that I am able to meet you at a conference or whatever it might be. But keep going. Sometimes it's hard, but just keep on keeping on. And with that, if you're celebrating New Year, Happy New Year. If not, I'm going to go call my mom, see how I did. But have a great afternoon.
Thanks so much for joining us.